Permutations with special cases. Permutation is an arrangement of items where order matters. When we have a special case, it's because there have been some restrictions on how the items can be arranged. Now the way to solve a permutation with the P and then M choose N doesn't necessarily work when there are restrictions. And I'm going to give you a cheat sheet of situations where this could happen. Phone numbers, words, and passcodes. How many ways can a phone number be created if there are 10 ways the first 3 digits can be arranged, and then each of the remaining 4 digits can be any digit 0 through 9 as long as no digit repeats within the group of 4? So one of the restrictions here is that the first 3 numbers can only be arranged 10 ways. And the other restriction is that none of the remaining 4 digits can repeat. So we're still going to make our spaces for the 7 digits in our phone number. But the first 3 digits can only be arranged 10 ways. So that's what that 10 is going to represent. Now, between 0 and 9, there are 10 possible numbers that we can use. And none of these digits can repeat. So for this digit, we have 10 choices. But whatever number we pick, we cannot pick it again. So 9, 8, and then 7. Again, multiply these together, and do not forget to multiply the 10 to represent the arrangement for the first 3 digits. Multiply everything together, and there are 50,400 ways we can create a phone number with these restrictions. Now, same question, but this time, how many ways can the phone number from above be created if the digits in the last 4 places can repeat? So very similar, we'll set up our 7 digits. The first 3 only have 10 ways that they can be arranged. Now the last 4 this time can repeat. So I have 10 choices, and then whatever I picked, I can pick again. So 10, 10, and 10. Multiply all of these together. Again, do not forget the 10 for the arrangement of the first 3. And we get 100,000 different ways or different phone numbers. We almost doubled the amount of phone numbers we have by allowing repetition. All right, one last example using a word. How many different 4-letter words can be made from the alphabet if the first 2 letters come from the first half of the alphabet and the second 2 letters come from the second half of the alphabet? And I say words in quotes here because I don't necessarily mean actual English words, just an arrangement of letters. So I'm going to make 4 spaces to represent my 4-letter word. This time I'm going to draw a line through it. Now I know that there are 26 letters in the alphabet, and the first 2 letters come from the first half. So that means I have 13 choices. And the second half of the word comes from the second half of the alphabet. Now again, this question was not specific as to whether or not the letters can repeat or not. So for this first part, we'll do it without repetition. All right, so if the letters cannot repeat, I have 13 choices and then 12. Now when I get to my 3rd position, I'm starting over at a new set. So I have 13 choices and then 12 again. Multiply everything together. And there are 24,336 words. Now if I want to do it with repetition, "13 from the first half of the alphabet, 13 from the last half of the alphabet." But the letters can repeat. So whatever letter I pick here, I could pick it again. Now this 13, it's from a new set of letters. So 13, and then whatever one I picked here, I can pick it again. So we are going to get 28,561 words.